Hello to you all, great 10 mindsetters. Welcome to your Learn Extra Live. This is a special show just for you because we love you and we love for you to learn more and learn extra with us. My name is AB, also known as Abram. I'm joined by Tracy. How are you, Tracy?
Fine, and you?
I'm also good. I'm feeling good.
Oh, yes. We're here again.
We're here again to learn more
Yes,
also.
Absolutely.
Because it's all about that. That's our business. It's about that.
Absolutely.
Nothing
It's
more,
important.
nothing less.
No.
Education-wise. What are
Yes.
we learning about today?
Today, grade 10s, we are going to do chemical reactions and calculations, probably the section you hate the most. In chemistry, we're going to look at the little bit of exemplar questions, the sort of questions you can get in exams, but specifically looking at the types of chemical reactions and calculations.
I like that.
Yeah.
Now, to help you revise more mindsetters, we have an exciting competition, which is our Learn Extra Live Marathon competition, brought to you by Samsung and Mindset, whereby you stand a chance of winning one of these coolest gadgets ever. It is a Galaxy Note 8.0. Yesterday, we gave away with one, and the other one was won 2 weeks back on our leg 1. So now we're on leg 3, whereby a winner also stands a chance of winning one of 3 tablets or one of 3 tabs, also proudly sponsored by Samsung. So we've got 7 more devices to give away. We're on leg 3. Watch that out. This Samsung Galaxy Note, it comes with an S Pen, which is this nice pen. Tracy nearly stole this pen from me because it's so nice. It's more like your pencil or your pen, and it has an 8.0 LCD screen. You see how big it is.
I so want one. You know what? if the 7th, if it doesn't get given away, I might steal it.
You might steal it.
No, I'm a good girl. Stealing's bad.
Yeah, stealing is so
Stealing's
bad.
bad.
We might surprise you, kinda. We might. Apart from that, it has a 1.6 gigahertz of your CPU, which is your memory. It's so fast, and 32 memory space for you, 32 gig. Enough for everything. And it comes also with the Samsung Learning Hub, whereby you can get your revision packages, material from the Learning Hub. So make sure that you enter for the competition, download the notes, get the race number. Because I'm also feeling like being a good guy, I'll give you the race number. It will be somewhere on the page. Use that race number to fill in the entry form. Remember, we are on leg 3. For now, join me on Facebook at facebook.com/LearnExtra and on Twitter at LearnExtra. Let's do this.
Let's do this. I so want that tablet. Anyway, yeah, it's okay. I'm a big
Christmas
girl.
is around the corner.
Didn't you promise me one last
No,
time?
it wasn't this. It was something else.
I remember this. There were thousands of witnesses last time, but it's okay. I'll get over it. Anyway, so what we're going to do today is we're going to look at some chemical reactions, grade 10. So hopefully you've done some revision, and obviously you might not have quite got there, but don't forget to download the notes. All the questions are there because they'll definitely help. Now, let's look at the first question, and it says to us that the unbalanced equation, so that's quite an important word here, so they tell me that it's unbalanced, and the word equation with 2 chemical reactions are shown below. So we have the reaction between sulfur dioxide, oxygen, and which gives me sulfur trioxide, then calcium carbonate, not carbonated, okay, calcium carbonate, which then gives me calcium oxide and calcium dioxide. So now they say to us, which one of the above equations represents, first of all, a decomposition reaction? So the first part of this question, grade 10s, is where you need to now decide, well, try and remember what a decomposition reaction is. So we remember that a decomposition reaction means that we go from a single compound to more complicated compounds. We decompose it, we break it up. Okay, so if we look at the first equation, we're taking 2 things and making it 1. That's definitely not decomposition. But in the second one, we're going from one thing, which is calcium carbonate, and we're making calcium dioxide and carbon dioxide. So that's definitely a decomposition reaction. So we would put 2. Then they ask us which is a synthesis reaction. Now, synthesis and decomposition are almost like the opposite of each other. Synthesis means that I take 2 or more smaller compounds or elements and I make a bigger or more complicated compound. So that would actually be equation 1 because I'm taking SO2 and O2 and joining them into 1. So that's the first one. So we're doing okay here. Then they say, what does the G represent in equation 1? This is the phases. Now, there's a big emphasis in the phases in the grade 10 curriculum, okay? being able to write gas, liquid, solid, or aqueous. Now, the nice thing is they're all exactly what their first letter says: gas, liquid, aqueous, or solid. So G stands for gas. And just to remind you, because we're going to need it a little bit later on, okay, that if there's an L, I'll write this nice and neat. Maybe I should steal Abram's pen. L, that's a liquid, okay. If it's AQ, that's aqueous. That means it's a solution dissolved in water. And S means solid. Not so bad, okay? Then, oh boy, write down a balanced chemical equation for the word equation in number 2. Show all the phases of the reactants and the products. So let's go over here. Calcium carbonate. So remember, calcium is Ca, carbonate is CO3, but now carbonate is a polyatomic ion, so carbonate is actually 2 minus, okay? So we want to remember that because we need to make sure we get this right. So now I want to go here to my periodic table. Come now. Periodic table, there we go. Remember, over here, calcium is Ca. Calcium is sitting in group 2. That means any of those that sit there have a valency of +2. So what I'm doing here is I'm working out what calcium carbonate looks like. So this is 2 plus, so when I put those two together, it's CaCO3. So that's the first part, CaCO3, and it's going to be a solid because we're going to heat it up and decompose it. Okay, and that gives me calcium oxide. Calcium is 2 plus, we've just worked that out. We go back to the periodic table, we find oxygen over here in group 16. That means its valency is 2 minus. Okay, so we go back here and we say, well, oxide is 2 minus. That means I only need one of each. And that's also going to be a solid. And then the last one in there, which you really should know by now, you've done it lots, is carbon dioxide, which is obviously CO2. And we know that carbon dioxide is a gas. But the question was, write down a balanced chemical equation. So now we're going to go, okay, well, let's look at this quickly. And we'll say, okay, 1 calcium, 1 calcium. Cool, we've got the same amount on both sides. 1 carbon, 1 carbon. We're happy, same on both sides. 3 oxygens on this side. That's 1 oxygen plus another 2. That gives me 3 oxygens, so it's balanced. So let's just get rid of all. Ooh, no, that wasn't what I wanted. Let's do the eraser. Let's get rid of all those little marks because you wouldn't have that in your exam. But that is a balanced chemical equation, and we're happy. Okay. Now they say to you, rewrite equation 1 and balance the equation. So let's have a look. We've got SO2 and O2. And in fact, you're going to see this equation lots by the time you finish school. Well, finish doing science. SO2 plus O2 gives me SO3. And straight away, I'm hoping you guys are looking at this and going, hang on, wait, Tracy. It's the oxygen that's the problem. And it is the oxygen. So a hint, and it doesn't always work, but it works a lot of the time, is try change odd numbers to even numbers, because you can always change an odd number to an even number, but you cannot change an even number into an odd number. It's one of those strange things. So if we look at this and we go, well, that's SO3. If I put a 2 in front of the SO3, I now have 2 sulfurs and I have 6 oxygens because I would multiply, I would multiply the 2 by the 3. So now I've got 6 oxygens. Now I'm going to come back to the left-hand side and I'm going to go, well, there were 2 sulfurs over here, so I need 2 sulfurs on the left-hand side as well. But now look what this has done. 2 times 2, that means I've got 4 oxygens over there, plus another 2 oxygens, that gives me 6. So it's balanced. Okay? Guys, this is one of those things you have to find a way that really suits you. Everyone thinks differently. You might have been taught to draw columns on the right-hand side and write it all out, and that's fine. It really is a personal thing, but you've got to you've got to work through knowing how to work it out. And remember that all your teacher wants to see is the final. They don't want to see you working out. They don't want to see all sorts of pretty diagrams and whatnot. So be careful, okay? Then they say, name the chemical law that a balanced equation illustrates. It's the law of conservation of mass, okay? Conservation of mass. And why do I say that? Because the total mass of this cannot change. So whatever I put in, I must get out. Whatever mass is on the left-hand side must be the mass on the right-hand side. So now they ask you, okay, use equation 1 above and show that the mass is conserved. You might have been taught this in slightly different ways, but you have been taught the concept of molar mass, okay? So we're going to do the left-hand side, okay? Or let's rather call that the reactants, okay? So we're going to start with the reactants, okay? And what we're going to do, all right, is we're going to take the mass of the SO2 and we're going to add it to the mass of the O2, okay? So now we go back to our periodic table and we go, fine. Sulfur is, where did sulfur disappear to? Sulfur's over here. The periodic table tells me that it has an approximate relative mass of 32, okay? And from our balanced periodic table, we actually have 2 SO2s. So I need to go, let me write this nicely for you. So what that means is I'm going to go 2 times, and here I'm going to add the mass of the SO2, okay? So sulfur is 32, and if we go back and we look here, oxygen has a mass of 16. Now, grade 10s, please be careful. The periodic table I'm using might look slightly different to the one you've been using. It's okay. Please just make sure that on the periodic table that you're using, that you look at the key. This is very important. There's been 3 periodic tables issued in the last few years, so sometimes we're not even sure which one we're supposed to be using. Use the one that's given to you, okay? And use the values given on that, whether it's got 1 decimal place, no decimal places, 2 decimal places, it doesn't matter, okay? Oxygen is 16, okay? So let's just close my brackets, and then this is 2 times 16 over here. Okay, now we really do need to decide whether we can do some math. So let's go over here, and we're going to have 32 plus, and 2 times 16, hopefully you can do that in your head. That's also 32. Wow. Stop it. Sorry, I've just got to talk to the, no, I want to turn it off. Ah. Okay, so it's very important to talk to your electronic equipment, just in case any of you thought about it. It's just very important. I'm a science teacher. You have to believe me, okay? So
it works for you.
It does, all the time. You can ask my kids. I talk to my version of a Samsung tablet all the time, and it works. It's great. Anyway, moving on. So we get 64. We're going to times that by 2. So that is 128. I know 2 times 16 is 32. And 128 plus 32 is 160. So essentially we have 160 grams of the sulfur dioxide and the sulfur. But now for our products, the product said to us that we had 2 SO3s, okay? So let me just go back here. We're going to put, for the products, it's the mass of the SO3. Okay, ooh, far too much. So that means we're going to go 2 times, now 32 for the oxygen, for the sulfur, 3 times 16 for the oxygen. So we're going to take out our calculator, so we're going to go, all right, so we're going to start with a clean slate. There we go, 32 plus, so I'm doing the sulfur trioxide, 3 times 16. So that's the mass of the sulfur trioxide, but there's 2 of them, so I'm going to times by 2, and look at that, we get 160. The mass before equals the mass after. Conservation of mass. The law is obeyed. That also means that my equation was unbalanced. Okay? So a little bit of a head explosion right there. So we're going to leave it at that, and it's time for a break, and then we'll carry on.
Right, mindsetters, remember also to get through to the notes, and then on the last page of the notes, look for your race number, and then quickly go to mindset.co.za/learn/win, whereby you stand a chance of winning, because we are saying with Samsung and Mindset, we're going the distance together. We don't want to leave you guys anywhere, but see you after the break. Welcome back, awesome mindsetters. Now let the learning begin and continue. Otherwise, if you're joining us right now, welcome. You've missed, but you can still catch up. If you are on the Facebook page, I'll highlight you because I see there are a lot of mindsetters. Keep your questions coming, and if you're stuck anywhere, go to also Mix It and submit your questions on our help desk. Tracy?
It's amazing how fast you can talk when you want to. It's hysterical. Okay, so now we're moving on to some more calculations, the fun part. And this is from question 8.1 from the exemplar. And it says to us that the reaction between magnesium and dilute hydrochloric acid is represented by the balanced equation below. Okay, so we've got magnesium plus 2HCl gives me MgCl2 plus H2. Okay, this is also an acid plus a metal reaction, which hopefully you learned a little bit about in grade 9, so you do remember this. And then it says during the reaction, during an experiment, 1,5 grams, so I'm just going to write that in because I like to write in the information I'm given, 1,5 grams of magnesium reacts with excess dilute hydrochloric acid, so we've got more than enough, to produce the hydrogen gas at STP. Remember, standard temperature and pressure means that your pressure is 1 atmosphere, or 101.3 kilopascals, and your temperature is 0 degrees Celsius, or 273 Kelvin. You haven't learnt about the Kelvin scale. You're going to do that next year. It's part of gases. It's actually really exciting. Then they say, calculate the mass in grams of the hydrogen gas produced. This is a stoichiometric calculation. So they want to know how much hydrogen gets produced. And that means I've got to work out from the magnesium how much hydrogen I get. So we're going to start off and we say, well, we've got the balanced equation, but I'm going to rewrite it over here because I'm going to need it. Plus 2HCl, which then goes to MgCl2 plus H2. Now, grade 10s, I need you to follow with me. I might now set it out slightly differently to the way your teachers have taught you, but it's okay. I promise you it's exactly the same content. The layout just looks a little different, okay? So what we're going to do is we start with the balanced equation always. Then we need to work out the number of moles of the known substance. What was I given? Which means I need to know the number of moles of magnesium. Okay, so I'm going to say, well, I want to work out the number of moles of magnesium, which is mass given divided by molar mass. My mass was 1,5 grams. I'm going to go to my periodic table. Okay, let's just get rid of all the nonsense I've written all over it. Okay. And, some more nonsense, there we go. And magnesium, let's just quickly find it. It's always good to know where it sits. Magnesium is over here, and its molar mass is 24, okay? So I'm going to come back here, so I'm going to do 24. So we do number of moles, so I'm going to go 1.5 divided by 24. And remember, we can't leave it as a fraction. 0,0625. I'm going to keep all those numbers, okay? But I'm not done, because that's the number of moles of magnesium. The question was, how many grams of hydrogen? So now I need to look at the relationship between the number of moles of magnesium and the number of moles of hydrogen. Now what's nice about this is that the magnesium and the hydrogen are a 1-to-1 ratio, which means for every 1 mole of magnesium, I get 1 mole of hydrogen. Okay? So I'm going to take my number of moles of magnesium, and to get the hydrogen, I'm going to take the 0,0625, and I'm going to multiply it by a ratio which I call want over got. Want is the number in front of the compound I'm looking for, divided by the number in front of the substance I have. And in this case, it's 1/1. Okay, so it's a 1/1 ratio. If if we had asked for how much hydrochloric acid is produced, then I would be multiplying by 2. Okay, 2 over 1. You must show that multiplication because we need to see that you understand the mole ratio. Okay? But we're not done because this is number of moles, and the question was how many grams of hydrogen. So I need to convert that into grams. So I'm just rearranging number of moles equals mass over molar mass. So now it's mass equals number of moles times the molar mass of hydrogen. And that one's a nice easy one because the mass of hydrogen is 1. There's 2 of them. So that means I'm going to times this by 2. So I'm going to go back to my calculator. I'm just going to take that answer times by 2. Ooh, or not. That's times by 2. 0.125. Okay? 0.125 grams. Not so bad. Now, they say to you, what is the volume of hydrogen gas produced? We know how many moles of hydrogen gas we've produced. They specifically said to you that this reaction happens at SDP, which means you need to remember that molar volume at SDP is 22,4 decimeters cubed. 22,4 decimeters cubed. Another piece of information on your information sheet. Remember, number of moles is volume divided by molar volume. So if I know that this is 0,0625, that's the volume I'm looking for. To get volume on its own, I'm going to have to, the wrong button. Let's go back here. There we go. I'm going to go, let's cancel this, 0.0625 times 22.4. And I will change this in a second. And that's 1,4. Okay? And now that means the units, 1,4 decimeters cubed. Hopefully you're sticking with. All this question is about mole ratios. Now they say to you, calculate the mass in grams of magnesium chloride produced. I want you to see something. Magnesium and the magnesium chloride, another 1-to-1 ratio, which means that the number of moles of magnesium chloride is also 0.625, but I'm going to write that in, okay? So the number of moles of magnesium chloride is going to be the 0.0625 times 1 over 1. So we've got the number of moles. Great. But they wanted the mass, which means I now need, because we know the equation is from here where I moved it around for the hydrogen, mass equals number of moles times molar mass. So I need to know the molar mass of magnesium chloride. So let's go back here and say, fine, let's work it out. Now, grade 10s, with the way I'm setting this out, where I put molar mass, which is M, and then I put the substance in brackets, that's a convention, because remember, you're now working out the third molar mass so far in this question, okay? And you don't have the question and then a space for the answer. You're just going to put a number and then put the answer, okay? Make sure your teacher knows what molar mass you're working out, which is why I go molar mass MgCl2, because now I know when my examiner comes along and he or she needs to come and mark this, they can go, okay, I know which one they're working out. So let's go back to our periodic table. Okay, magnesium is 24, chlorine 35.5. So that means this is going to be 24, and we have 2 times 35.5. So I actually have 24 plus 71, which gives me not 85. That would be just ridiculous. That gives me 95. But you know what? Let's just double check my maths right now. Because, no, wrong one too. Let's do here. Okay. What I'm going to do, though, because I want to make sure, please just pay attention to what I'm doing here. I'm changing the display of my calculator. So I'm going to go to linear. Okay. So it's got to be on 2, because then it's going to make our lives easier. So we said we're going to 24 plus 2 times 35.5. Okay, I'm right. It is 95 grams per mole. We just have to be on the safe side here. Ooh, wrong one, come on. Really? There we go. Okay. Not done yet. That's just number of moles. The question was mass. So the mass, let's make this a little bit higher, is, no, wrong way. Okay, I've written it. Sure, it did all sorts of things all by itself. Just saying. There's a ghost here. It is almost Halloween after all. Okay, number of moles times molar mass. So it's 0.0625 times 95. This I definitely can't do in my head. So I'm going to take the 95 times 0.0625. 5,9375. We're going to round that off to 2 decimal places, okay? Come now. 5,94 grams. Sure. These aren't nice numbers. They never will be. We take our time. I am going through it fairly quickly, but I'm sure you guys are okay. Now for the fun question.
Can I quickly ask you a question?
Yes, go ahead.
Here's a mindset asking that what if you're given a periodic table whereby the molar mass is not rounded off? Do you need to round it off, or must you just leave it like that?
You must use exactly what's on your periodic table. And where that comes from is when they first brought in the new curriculum, they gave us these periodic tables with all these decimal places, like particularly with the hydrogen. You've probably got one that says that hydrogen is 1,001 or 1,002. Use it as it is, exactly as it's given on your periodic table. Do not round off. Round off at the end, but not during the middle, because your teacher will work out their memo according to those values. So it'll be slightly different, so make sure you use them as given. It's not nice, and it'll settle. It's just because we were given, and it's not wrong. Guys, there's nothing wrong with that periodic table. In fact, probably it's a good idea for you to Google the periodic table. It's one of my fun things. And you'll actually see that on most periodic tables, it can go to 5 or 6 decimal places. So we rounded off at school level to make the calculations easier. And I think they probably left it as more than 1 decimal place originally to make it more accurate. And then realized, it's horrible to mark. So it really is about us. It's got nothing to do with the kids.
All right.
So hopefully that helps.
Yeah, Tatars,
Okay?
I hope you helped with that one.
I hope so
From
too.
Tatars.
I know, it's so frustrating. I know. Okay, then they say, now we need to calculate the number of chlorine atoms. Ooh, no, that's an eraser. That's not going to help us. Atoms present in MgCl2. So now we've got to go back and think, okay, I know how many moles of MgCl2 I have. Number of moles, 0,0625. That means I have 0,625 moles of magnesium and twice as many for chlorine, because in every magnesium chloride molecule, there are 2 chlorine atoms. But they don't want that. They didn't want number of moles. They wanted to know how many, which means we've got to go back to Avogadro's number. And remember, Avogadro's number is that nice big number, which is, you would have learnt it, and 6,02 times 10 to the 23. 6,02 times 10 to the 23 will be on your information sheets, okay? You're not expected to remember that number. But every mole of a substance has 6,02 times 10 to the 23. We only have a part of a mole, but in every one atom, we have 2 chlorine atoms, or ions, okay? So that means when I say number of chlorine atoms, because I've got to tell them what I'm working out, that means I'm going to take the fact that there's a little 2 there, times by the number of moles, and then I'm going to take that and times by Avogadro's number. That tells me how many atoms there are. So now we go back to our calculator. No, geez, I keep doing that. Calculator is over there. Now we know where it is. Okay, so let's just cancel and make sure we can all put this in. So we're going to go 2 times 0,0625 times, now watch, 6.02. Use your exponent button here. Please don't do times 10. Use the button that's there, and it's to the 23. and look at that ridiculous number. 7,525, so that's 7,53. And it was times 10 to the 22. Not a chance can you count that much, okay? Not a chance. This number is ridiculously big, okay? But the reason and the big thing here is that I times by 2 because of the 2 in the MgCl2, okay? Lots of extra concepts done in that section. I think their brains really have exploded. I think it's time for a quick drink break.
I think we should do that.
Water, you're too young. Water or coffee.
Right, as you get that water or coffee mindset is, remember also the rest number is on the page, somewhere there on the page, and you could win yourself one of the awesome Samsung devices, maybe a tab, maybe a tablet, or a Note 8.0. Otherwise, see you after the break. Welcome back, awesome great hands. We're enjoying the show as much as I think you are enjoying it. If you are enjoying it, let us know on Facebook, because on this side it is just so much fun. Otherwise, on Facebook we have some comments and questions.
Okay, all right.
Let's start with a comment.
Okay.
Tato Marumo says, "I am so fried."
I'm sorry, sweet pea. Yeah, it's Halloween. They're allowed to be frightened.
Aww.
But you got to get over it. Hopefully after watching the show, you're not going to be so frightened.
Let us know
Okay?
after the show how you're feeling.
I know, but it's all about practice, practice, practice.
All
Yeah.
right.
Yes.
Here's a question from Mukove. How can I know that a compound is a solid, liquid, or gas?
Okay, sweet, that's a very good question. Most of the time, like things like the calcium carbonate and that sort of thing, it's something that you're gonna hopefully have seen before, or you can pick it up from the question. So if it's in words, now it was a bit more difficult with the first one there, but they will tell you that solid carbon dioxide reacts with oxygen. Now, what you should realize is things like oxygen, carbon dioxide most of the time, hydrogen, those sort of things are always gases, okay? Your acids like hydrochloric acid, nitric acid, that sort of thing will always be an aqueous solution. Most of the time, your compounds, your ionic compounds, which you should have learned how to identify, will be solids. So the sort of thing that they expect in there are the ones that you expected to know. Also, and we might not get time there, but in the notes there's a fourth question which has to do with precipitates and soluble and insoluble precipitates. So learning the rules of precipitation and solubility will then help you know what won't dissolve, and pretty much everything else will. So you can assume that in a reaction they're then aqueous. So it's one of those things, unfortunately, at this stage, you're going to have to learn them as you go along. And maybe, as you're doing problems, start making notes for yourself. Make a little list of what you normally see things as. Like SO2 is normally a gas, CO2 is normally a gas, that sort of thing, because that'll help. The more you see it, the more it starts to become ingrained. Like I know, I've been teaching for 17 years. Older than you've been alive. And probably older than he's been alive too, but let's not go there. No, he's a little bit older than that. But the point is, I've been teaching for so long that it's just something I see all the time, that for me it's second nature. So I forget sometimes you don't always know. It comes with just learning,
Experience.
basically. Yeah.
Experience also.
Yeah.
Here's I don't know if you would think actually this is a silly question. What happens when you mix acid with acid?
Acid with acid.
Yes. That's what RCJ is asking.
So something like hydrochloric acid and sulfuric acid. I guess nothing, actually, because they might swap partners, but they'd stay what they are. Probably nothing. You get a more concentrated acid of some sort, I'd imagine. Probably
Maybe
makes
you
it
need
more
to
dangerous.
be more specific, mindset. Be specific on your question.
I think what you might be asking me is what happens when I mix an acid plus a base. Then I get a salt plus water. But an acid plus an acid, never seen that before.
And now a producer says you get it fried.
You get it fried. There we go. And I'm frightened. I'm glad I'm not working on Thursday. I have to be honest. I think the live shows on Thursday are going to be interesting.
Really?
Well, you never know.
Well, let's just wait and see.
I don't trust.
Because I think the interesting part also will be, I think that there'll be a giveaway on Thursday. We'll be doing our leg 3 giveaway.
Ooh.
So
Watch
there's so
on
many
Thursday.
things happening.
Can I enter through for someone else? No, I can't.
No.
That's bad. That's illegal and against the rules. Okay, got another question for me.
No, not yet now.
All right, so I'm going to jump right in. Now, probably out of all the questions we're doing today, this one's the most difficult, so stick with me. They say to you that the molar mass of sodium carbonate is found to be 269 grams per mole. The formula of the hydrated sodium carbonate is Na2CO3 dot XH2O. Now what that dot XH2O means, it's not multiplication. It means that if I take the sodium carbonate molecule, around it is a whole bunch of water molecules as water molecules attached to it. Now they say calculate the number of moles of water crystallization, in other words X, in the compound. So now we're going to say, okay, they found that the molar mass of the whole compound, Na2CO3, okay, is 269 grams. Ooh, 269. Maybe I should write the whole number. How does that sound? Ooh, and you know what? This board does not like me. But we know this. We'll get over it. Maybe if I spoke nicely to it. What do you think?
Maybe.
Maybe. Anyway, so 269. So now we're going to break this up. The molar mass, let's do the molar mass of sodium carbonate on its own if it didn't have everything else. Okay, so just the sodium carbonate. So we go to our periodic table and I realize sodium is 23, carbon is 12, oxygen is 16. Okay, so we've got 2 sodiums plus 12 plus 3 times 16. Okay, so we're going to go here. We're going to 2 times 23 plus 12 plus 3 times 16 gives me 106. Oh, I had this with today when I was teaching. My kids were moaning that they couldn't read my handwriting, so maybe it's me. Okay, that means of the 269 grams per mole of the sodium carbonate crystal that we have, only 106 grams per mole is the sodium carbonate. That means the number of moles, now watch what I'm doing here, okay? The mass of XH2O, the whole of the water together, okay, is going to be 269 minus 106, so it's 163. The question was, what is X? Okay, now I didn't leave myself enough space over here, so what I'm going to quickly do is I'm just going to make myself a little bit of space. Okay, and now I want to find X. Remember, the molar mass of water, just plain water on its own, is going to be 2 times 1 for the hydrogen plus 16, so that's 18 grams. Okay, 18 grams per mole. So watch. X is going to be equal to the molar mass of that whole H2O, okay, divided by the molar mass of just H2O on its own. So in other words, it's 163 divided by 18. So let's just see what we get. 163. Oh, maybe I should put the whole number in. 63 divided by 18. And we get 9,05, blah, blah, blah. Okay? So we're going to put that as 9. And I'm putting it as 9 because I can't actually have part of a molecule or 9.1 or anything like that. So there's actually 9. X is 9. There's 9 moles. Why is there a decimal? Because we're using rounded off values on the periodic table. Okay? If we weren't using rounded off values, then it would be easier for us to do this, but we are using rounded off values, so there's nothing I can do about that. Okay? This is a mean question. This is a very mean question, but it's a nice question because it really starts to show your understanding. All right. Then, empirical formula, and I can just hear the groans. They tell you the empirical formula of a certain compound is to be determined. On analysis of a sample of the compound, it was found to contain 71.65 grams of chlorine, 24.27 grams of carbon, and 4.07% of hydrogen. So what they do is they do a whole bunch of analysis. They take it, they break it up, they burn it, they mix it with a whole bunch of different chemicals, and they do it. It's quite complicated, but then we get the percentage. From here, I can now calculate the empirical formula. But now the first question is to define empirical formula. Empirical formula is the simplest ratio in which the molecules, the atoms in a molecule will bond. Simplest ratio. Okay, simplest. Cannot have decimals in it. Okay, they can all be ones. They can't all be the same number. You can't have a common factor. Must be simplest ratio. So, let's get started. Now with this one, as with everything else, your teachers might have shown you a slightly different method. Please don't stress about it. Make sure, though, you show them exactly what you're doing. I'm pretty sure we all do it the same way because it's really the easiest, and we'll go from there, okay? Now, they give us the sample as percentages. Now, we all know that when we add all the percentages together, we should get 100. So what we're going to do is we're going to start and assume that we have a 100-gram sample. Because if I have a 100-gram sample, then 71.65 grams will be chlorine, 24.27 grams will be carbon, and 4.07 will be hydrogen. Now, I'm looking at these numbers, and I don't think these will quite add up to 100, but it's okay. We're still going to go from there, all right? So we are going to write in that we're assuming a 100-gram sample. We need to set, I mean, we could assume a 10-gram sample if we wanted, or a 50-gram sample, but then it just becomes difficult with the percentages. So let's make our lives as easy as possible. I mean, I know with the maths, I'm actually quite lazy, so I'd prefer not to be difficult. So I have 71.65 grams of chlorine, 24.27 grams of carbon, and then I've got 4.07 grams of hydrogen. Now, I'm going to set it out so I do all three equations next to each other. I like to keep everything in line. Okay? Now, the first thing I'm going to need to do is I've got assumed a 100-gram sample. Now we're going to convert this into number of moles. We do not consider the fact that chlorine and hydrogen are usually diatomic. So in normal circumstances, I would use H2 and Cl2, but this is not normal. We use them as single atoms. So what we're going to do is that we're going to work out, and I'm keeping it under the chlorine. Remember, number of moles is mass given over molar mass. So this is 71.65 divided by 35.5, because we know that from the periodic table. So this 71.65 divided by 35.5, and we get 2.02. Let's round it off to 2 decimal places. So that's how many moles of chlorine. Let's do the same for the carbon. Okay. So this is 24.2 divided by 12. Wrong one. Let's go here. And 24.2 divided by 12. Oh, look at that. 2.02. No, come here. I'm liking this so far, because I'm getting numbers that are looking the same. Let's do the hydrogen. Maybe I should write this so you can read it. All right. So 4.07 divided by 1. Do I really need to do this in the calculator? I hope not. So this is 4.07 moles. Okay, I guess it's all complicated. It's all right, we can manage this. So now what that means is, if I go chlorine to carbon to hydrogen, now I want the ratio in which they're bonding. So this is 2.02 to 2.02 to 4.07. But that doesn't help me, because I can't use decimals. And I need to try and get something down to a 1 if I can. So I'm going to divide by the smallest number, which is the 2.02. So I know that's going to be 1. I know that's going to be 1. So let's just, I want you to see this. 4.07 divided by 2.02 is 2.014. We're going to round that off to 2, because really to keep the 01 doesn't make any sense here. So we're going to round it off to 2. So that means I've got 1 chlorine, 1 carbon, 1 hydrogen. Now, knowing the order that this needs to go in, this was a bit mean because they actually didn't put it in the order that you need to write it, because it needs to be CH2Cl, which is quite a strange little compound, actually. It's a very strange little compound, okay? And that's the empirical formula. This is not molecular, okay? How do I know that the chlorine goes last? Because the chlorine is your negative ion. Okay, so when it comes to this, your negative ion needs to go at the end. Hydrogen would be positive, and carbon always comes before hydrogen. So the Cl goes at the end. If you wrote it this way around, I'm going to assume I would accept it. Okay, your teacher might not, because this is technically the correct way. And you should at this stage be able to recognize which way around you need to put the order. Okay, but the order they gave it to you was this because of the percentages. They gave it to you highest to lowest. Okay, so hopefully we've all got that. So you're going to assume a 100-gram sample. You're then going to work out the number of moles without considering the diatomic. Once you've got the number of moles, you're going to reduce it down to the lowest ratio between the numbers, and then you can write your empirical formula. Okay? Do we have some questions? Because you look all eager to ask me.
Here's a question.
Yes.
Ambani says, if a question comes with the wrong periodic number, do you have to draw a Lewis structure or what?
Huh? I'm not really sure what he's asking.
If
me.
a question comes
Yes.
with the wrong periodic number.
Periodic number. I'm not sure what that is.
Mm-hmm.
Sweetie, I think you just need to define what you're asking me, because if the question gives you, say, like and you might be meaning maybe the atomic number, you must use the information given to you in the question as laid out, even if it's slightly different to what's on your periodic table, because remember, we get isotopes. Lewis structures you'll only draw if you're asked to draw a Lewis structure, which would only be asked to draw when you've got to do the shape of a molecule or that sort of thing. And they use your periodic table. I'm not sure they would give you the wrong numbers. I'm not 100% sure what he's trying to ask me there, but I'm hoping I sort of covered it.
All right. Let's take another one. Can you please define the term empirical formula? I think
Again,
a lot of mindsetters are
I
confused.
went quite quickly. The empirical formula is the simplest ratio in which the atoms bond in a molecule. Okay? It's the simplest ratio in which the atoms bond in a molecule. Simplest, simplest, simplest. This molecule would probably actually be C2H4Cl2 in reality. Okay? That's probably what it is, because the bonds don't make sense here. But this is empirical. Simplest formula, simplest ratio in which the molecules bond. And I think I've run out of time.
Right.
Sorry, guys. But what we are going to do is we're going to finish off electricity not electricity. I think we did electricity last time. We're going to do some more physics next time. So when I see you next week, we're going to do physics. Hang in there. Keep studying. Practice, 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 practice. And
Right.
Yep.
And all the best for your test. Some mindsetters are saying they're writing on Friday. All the best, mindsetters, because we're here going the distance with you, making sure that we help you all the way. Enter for the competition. Remember, it's on mindset.co.za/learn/win. From us to you, we just want to say, yours in peace, us, me, Abram, and Tracy. We love you so much, and peace.